Okay, the last part of the video of the notes here is just to finish up with more equation conversion. We're still looking at rectangular going to polar. And, some of them are going to be kind of simple. Some of them you might, like the last couple, be able to sort of reason out a little bit based on, thinking about the graph itself and what you might expect to get. Some are not like that. But as I look at these two examples with only x, and I look at my choices off to the side, there are not a lot of choices. But I think one that sort of stands out is one I would probably use. Would be this. Now, for starters, when I set it up, remember that after the first substitution, you might feel like, I'm done, I've got it in polar. But again, polar equations tend to read r equals or theta equals, so we need to solve it for r. See if you guys can think about what this would be without me showing you any work, and then I'll show it to you in just a second. So do your normal algebra, do a little bit of identity. What is it? Now, if you said 7 secant theta, then good. What you saw was that. And 7 over cosine is 7 secant. Use the same reasoning, the same logic to do the second problem. Now, right away when I see y, I'm thinking of this. Again, I'll do my real quick substitution. If you think about it, just by doing the same little quick algebra and identity, you're going to get so now in this case, I don't think you would look at the polar version of the equation and go, yeah, that's a horizontal line or that's a vertical line. So they don't always translate in your head as, I can tell ahead of time, but otherwise just using algebra and identity. Now, going the other direction, polar to rectangular, you will have some equations, again, if you just sort of think about it for a second. You could probably actually create the equation without much thought, without having to do a lot of work from the list on the right-hand side. If I gave you r equals 12 as a geometry question, and I said, write me the equation of the circle, you guys would probably be a couple seconds. X squared plus y squared equals 144. What r equals 12 means, the polar equation is, that is, radius 12, any rotation line. So I talked about this earlier in one of the other parts of the notes. But if you thought about that, let's just say this out here, we'll call this 12, even though it's not. But if you go any rotation line radius 12, and that's true positive or negative, you're going to create a circle. So r equals a number is really just the equation of a circle. Now, if you're trying to say, well, if you do say to yourself, I don't know if I would have saw that, then maybe think about it like this. So x squared plus y squared equals 144. Now, also, next one, theta equals pi over 4. If you think about theta equals pi over 4 as a polar graph, and what that actually means, if I'm interpreting that as a polar graph, is that's the pi over 4 rotation line, radius anything, plus and minus. So rotate to the pi over 4 rotation line and go out 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, and so on. But what I'm doing is creating an equation of a line. Now the factor sitting on the pi over 4, what if this graph was on an xy axis? That's the line y equals x. If this occurs to you, great. It will help you probably understand better like how it is that theta equals pi over 4 turns into y equals x. If you don't visualize it as, kind of comparing graphs, which you don't need to do, then it's like, what in the list off to the right-hand side am I going to use? Well, anytime I see a theta, I'm thinking of this. And what I do is a substitution, where I say tangent of theta, and I plug in my theta. Well, the tangent of pi over 4 is 1. If y over x equals 1, then y equals x. So that kind of conversion is totally, a way to go, and you probably will end up having to do that anyway, just as a way to show some work. But in these two examples, I think you can actually sort of tell ahead of time what you're going to be dealing with. Okay, just a couple more here and we'll wrap it up. And again, some are going to be quick and easy, like for example, this fourth one. I mean, r sine equals 3. I don't really need to give this much thought. Y equals 3. Okay. So that actually is the equation of a horizontal line going through 3. Now the last one, it has a little bit more to do. I mean, it's like I said, like the one right above it, 2 seconds, I'm done. But as you look at the next one, you know, it's like, well, where are the substitutions? And, you know, I've got r on the one side, I've got sine of theta. There are some things in the list that I could do, but they're not, you know, r, if I'm going to choose to work with r, that's got a square root. If I'm going to choose to work with sine of theta, that's got some other stuff in it. It's like, you know, that might make the problem actually kind of somewhat harder, you know, more difficult to do than it needs to be. So actually, I kind of look at this one as sort of an algebra approach. What I'm seeing is you know, something equals a fraction, and my typical algebra response to that is, you know, let's get rid of the fractions. So let's multiply both sides by the denominator. Then I'm going to go ahead and distribute that r in. So I've got r plus r sine theta. And then at this point, I can start to see a few things showing up. I see a y in there, so that's good. But how do I deal with the other r? That's kind of the other question. And the 1. And remember, what we're trying to do is go from polar to rectangular, so we need an xy equation. But I'm going to at least start with the idea that I can replace this with a y. Now, what I often see as kind of a mistake in a problem like this is people will solve this for y, go y equals 1 minus r, and say, well, there you go, I got it because I got y equals. But the problem is you still have r in the equation. And to go from polar to rectangular, you have to eliminate r and theta completely. So what I like to do in a problem like this is I'm going to actually get the number and y together on one side and just have r sitting by itself. So here's how that's going to work. And then I do actually have a way to substitute r out of the problem, which is to use the square root. Now I kind of like to sort of stay away from this one. And the way I stay away from that one is by trying to work with the r squared. Just because I don't have the root, it seems like it'd be easier to do. To do that substitution, what I'm going to have to do is square both sides. So r squared now becomes x squared plus y squared. The other side, if I FOIL it out, would be that. Now solve this for y. Well, the y squareds would drop. Subtract 1, divide by negative 2. You're going to get now that's a rectangular equation. It actually turns out what I have is the equation of a parabola. It's quadratic. So that polar equation, the original one, was actually the equation of a parabola. So you can see that when doing the conversion of equations, there's going to be kind of like doing identities in a way. There's quite a bit of variety going on. And, you know, not as nearly as many things to choose from as far as substitution. You don't have the big identity sheet. You just have that kind of list of 5 things that were on the side. But it's a little bit of creativity, a little bit of substitution, a little bit of algebra. That's pretty much it.